Send the answer to me on WhatsApp once you are done, okay? Raise your hand if you have not done anything till now. Like you're completely stuck. Raise your hand if you're completely stuck. Okay, you guys are doing. Okay, please send the answer if you have calculated either in terms of hours, minutes, or seconds. If you have calculated in any one of these terms, now please send the answer to me. Okay, Hanifa, Nawal, and Rifat, please send me whatever you have done. Guys, please send me whatever you have done till now. Nawal, what is N2O2?
So I'm into 5.
Okay, fine. Also, the change is always final minus initial, okay? Whenever you write delta of any reactant A, this is the concentration of A, that is final, minus the concentration of A, that is initial. So when you're writing average rate in the terms of this reactant, you should see that, okay? Also, like, just make sure that you are not calculating the rate as rate of disappearance or rate of appearance or the rate of reaction as a negative number. It should always be positive. What about others? Rifat and Hanifa? Please answer na, jaldi answer kijiye. What happened?
Sir, my phone is switched off. Sir, my phone is switched off. It'll take a minute, sir.
Okay.
I'm not able to do this one.
You're not able to do this?
No.
Where you presented the last lecture, Hanifa?
Yeah, I was there.
Sorry?
I was there.
Okay. So tell me, we wrote about average rate, yes or no? Yes.
Yeah.
What is average rate?
Change
Now,
of concentration.
now we have been given, okay, first of all, tell me, we have been given the concentration of reactant or product? We have been given the concentration of reactant. It is what? It is minus C2 minus C1. That means final minus initial upon the delta T, the change in time. Delta T has already been given as 184 because after 184 minutes, we saw this change. So this average rate will be equal to negative of the final concentration is what? Tell me, Hanifa, what is the final concentration of N2O5?
2.22.
2.08. Initial concentration was 2.33. Right. Delta T is equal to what? 184. This is in minute. This is in moles per liter. Right.
Yes.
Okay. And also one more thing, since as you can see that this 2 is there, right? So it will be multiplied by its half also. Because rate is the rate of disappearance of the appearance divided by the stoichiometric coefficient.
Yes.
Okay, so this will come as 0.25 minus 0.25 plus 0.25 will become that and divided by 184 into 2. This will be equal to 1 upon 0.25. I can write as 1.4. So it will be 184 into 2 into 4, right? So this will be in moles per liter per minute. And then you just need to change the time 184 minutes to hours, 184 minutes to seconds, and then you will get the answer. This was the basic idea. Actually, right next. Factors affecting the rate of reaction. So, factors affecting rate of reaction. Please write number 1. The concentration of reactant. Secondly, temperature. Thirdly, we are also going to learn about the presence of catalyst. Okay. Now there are some more factors that we are going to learn, but these are the 3 main that we have to keep in mind. Okay. Nature of reactant and product. Fifth is the surface area. This is explicitly for solids. Then sixth one is exposure to radiation. Okay. So please, in examination, आपसे ही पे सवाल किया जाएगा बस इन तीनों के बारे में, but we'll talk a few things about these factors also. Write this down. लिख लिया आप लोगों ने?
Yes, sir.
All of you done?
Yes, sir.
The basic idea about a reaction is that whenever if there is any reaction that is happening, it will be only happening. So let us say, for suppose example, we have A plus B, and it is going to give me AB. That means we should have A molecule, and there should be another B molecule, and these two molecules should collide with each other, and then only what can happen? Then only they can form AB. Then only they can form the AB molecule. Then only they can form the AB molecule, right? That means the collision is an important criteria. Collision is an important criteria. Now, if I am going to increase the number of collisions, okay, if I say if number of collisions increases, then I can say reaction will be faster. Yes or no, guys? Please tell me. Can I say that if the number of collision will increase rapidly per unit time, then the speed of reaction will increase, right? For example, if let us suppose there are 10 collisions happening per minute, and in another case there are 150 collisions happening per minute, then obviously the 151 will be having higher rate. Yes or no? Please tell me, Hanifa, Rifat, and Nawal.
Yes.
Yes.
Right? As simple as that. Now, how can we increase the number of collision? What we can do, a basic simple thing that we can do is we can increase the concentration. Okay, we can increase the concentration. If we will have more A molecules, if you will have more B molecules, they are going to obviously collide more often. Then they are going to collide more often. And this very basic idea they took and they stated the law of mass action. Please write. Law of mass action. Please write according to this law, rate of reaction is directly proportional to the product of concentration of each reacting species. is reacting species at a particular temperature. That means they are saying if I have a reaction in which A plus B is giving me the product, then they are saying the rate is directly proportional to the concentration of A. They're also saying rate is directly proportional to the concentration of B. And they're also saying the rate is directly proportional to the concentration of A and concentration of B. That means, and this is going to give me the rate is equal to some constant into the concentration of A into the concentration of B. Then guys, so see, this is known as the rate constant. This K known as the rate constant. Write a word about rate constant. What is rate constant? Please write. Now, write for rate constant. It is defined as just a second. Please write. It is defined as rate of reaction it is defined as rate of reaction when concentration of each reacting species is 1 mole per liter. Okay. So rate is given as what? According to the law of mass action, K into the concentration of A into the concentration of B. Now let us suppose if the concentration of A and the concentration of B both are equal to what? Both are equal to 1. In this case, what will happen? The rate will be equal to the rate constant. So we say that the rate constant is nothing but it is the rate of reaction. Okay. But there is a certain condition. When the concentration of A, all the reacting species is going to be what? 1 mole per liter. In that case, whatever the rate of reaction comes to be, that is going to be the rate constant. Okay, so please write one more line. Rate constant is also called specific reaction rate. Specific का मतलब एक specific concentration पे, right? And what is the concentration? 1 mole per liter is the concentration. Okay. Right, next. Characteristics of rate constant. Item number 1. It gives an idea about It gives an idea about the speed of reaction. Greater the value of rate constant, faster is the reaction. Right, next. Different reactions have different values of rate constant K. Have different value of rate constant K. Right, the third one. Rate constant is independent. Rate constant is independent of concentration of reactant. If rate constant, it will only depend on the temperature. Rate constant changes with change in temperature. All of you done? Yes or no, please tell me.
That's
Done. Okay. So see, these are important points. That means the rate constant, it gives first of all an idea about the speed of the reaction. If the rate of reaction is higher, that means what it is saying. That means if you are taking 1 mole and 1 mole, then it is going to be what? It is going to be that speed. If the rate constant is greater, that means the speed of that reaction, the rate of that reaction is itself very high. And if you have the rate constant of two different reactions, then you can compare which of the following reaction is going to be faster. The one which is having higher rate constant is going to be faster. Then obviously different reaction, they will have different rate constant, and the rate constant is not dependent on the concentration. Okay, you may feel like नहीं such a एक यहाँ पे मोल था, if this was 1 and 1, तो rate constant कुछ आया था. That is true. That is used to calculate the rate constant. Okay, that is used to calculate the rate constant. And if this was also equal to what? 2 molar and 2 molar, at that time also rate constant will be the same. Rate constant does not depend on the concentration. It just depends on the what reaction you are going to do. What reaction you are going to do. Okay. Now let us come back to this law of mass action. Okay. And let us suppose that we have a reaction in which, as you have seen the one reaction, that is nucleophilic substitution reaction. In that, what happens? We have Rx, and then there is nucleophile, and then we get Rnu plus X negative, right? And this is the basic nucleophilic reaction. Now we said that this can happen in two different ways. It can either happen in two steps, in which Rx, it is going to give the, it is going to leave, X negative is going to leave in first, and then the nucleophile is going to attack on the carbocation, leading to the formation of CNU bond. Okay, and in one case, what can happen? The nucleophile, it is going to attack on the carbon, and at the same time, the X is going to leave. This is a single step reaction. Now, on the basis of this, we saw that in this case, this reaction is majorly determined by this step. If this step is faster, that means the reaction is going to be faster. Okay, now that means the reaction, it does not always depend on what, it does not always depend on the both of the reactant. Sometimes it will depend on only one of the reactant, or sometimes it will depend on both of the reactants. Sometimes it will depend on one of the reactant, two of the reactant if there are three reactants. Okay, so for that case, what we found out, that law of mass action was completely theoretical. It said that, and it also predicted that we can get the rate of reaction by just looking at the particular reaction. If I have A plus B, and it is giving me some product, and rate of reaction is going to be, if you have the rate constant, then you can predict the rate of reaction at any particular concentration. You can predict the rate of reaction at any particular concentration. But that is not the case, because different reactions, they have occur via different mechanism, and due to different mechanism, there are different rate determining steps, and they determine what is going to be the actual reactant which is going to play an important role in determination of the reaction rate. So for that, it was given rate law, and this rate law is always experimentally determined. Okay, so please write rate law. Okay, law of mass action is just there to show you that it is directly proportional to the concentration. Rate of reaction is directly proportional to the concentration of the reactant. But rate law is the mathematically determined experimental rate law. So please write for this rate law the mathematical expression in terms of concentration of reactant which actually determines the rate is called rate law expression. Okay, now what is the difference between the law of mass action and the rate law? So see, for a general equation in which we have AA plus BB giving me CC and DD. So the law of mass action it said that rate will be equal to, so please remember here what do we have, if I have 2A ना, that means आपके पास ये A के है, ये दूसरा A, उसमें आपके पास rate of reaction is going to be what, A का square, but here we have A A's, that means A times A, so it will be what, A to the power of A and B to the power of B. This was what law of mass action said. But rate law says that you cannot say that it is going to be directly proportional to the stoichiometric coefficient of the reactant and the product. It says that rate will be equal to, sorry, there will be a constant, rate constant here, rate constant into the concentration of A to the power, you can write P or Q or M or N. Okay, and this P and Q are what? P and Q, first of all, may or may not be equal to A and B. Okay, may or may not be equal to A and B. Also write one more point, P and Q can only be experimentally determined. Can only be experimentally determined. Okay, but as you can see, A and B को determine करने की जरूरत नहीं है, आपने जैसी equation लिखा पेन से आपने, you didn't have to go to lab also, but for P and Q you have to go to lab and then get the values. Okay, please complete till here. Done, guys? Yes or no? Tell me.
Yes, sir.
No. Write a note. First of all, write law of mass action is a theoretical concept. And is associated with balanced chemical equation. Next point. Rate law is experimentally determined and it may or may not be associated to balanced chemical equation. Done all of you? Yes or no? Please tell me.
Yes, sir.
Okay. Now those P and Q that we wrote now, those are known as the order of reaction. Please write next topic, order of reaction. Please write here. It is defined as the sum of power of concentration terms, power of concentration term raised in the rate law expression. Okay. So for example, if the rate law says that rate is equal to K into the concentration of A to the power P and the concentration of B to the power Q, and we will say that the order of reaction is equal to the sum P plus Q. Okay. And what is P? P is the order with respect to A, and Q is the order with respect to B. Okay. Read some questions. आपने लिख लिया था? All of you have written this? Yes or no? Tell me.
Yes.
Yes. Okay.
Yes.
Yeah. For example, you have that A part. They have given rate is equal to K into the concentration of N2O5. So what will be the order of reaction? Tell me. कितना power है N2O5 के ऊपर? What is the power of N2O5? अरे, tell me. कितना power है यहाँ पे? Loudly, Hanifa.
1.
1, right? Yeah. Order of reaction is going to be 1. लिखते जाइए, ठीक है? Write the order of reaction and send the answer on my WhatsApp. Yes, Nawal. First one is correct, second one is correct, third one is correct, fourth one is correct, fifth one is correct, sixth one is also correct. Very good, Nawal. Quite easy. And इस तरह के सवाल आते हैं, ठीक है ना, एग्जाम में. Like you can get this type of question also in the examination. Even though it is very easy, ये भी आपको शायद 1 मार्क्स में मिल जाए. है ना. फॉर एग्जाम्पल आपके पास देखिए ये सवाल आया हुआ है 2013 में. व्हाट इज द ऑर्डर ऑफ रिएक्शन? या हनीफा, करेक्ट, वेरी गुड.
Sir, can I send my answer in chat?
No, tell me, no, just tell me what are the answers. For B it is how much?
1.
1. For C, order of reaction is
1.
1. Here,
2.
here,
3.
and here.
2.5.
Okay, and here 2.5. Okay, check. Now write some remarks regarding order of reaction. Is right. It is defined as sorry. You have written this, no? The definition you have written, right? It is experimentally determined. It is experimentally determined. Next is it can be. Actually, it can be 0 also. Okay, for some of the cases you'll get K into the concentration of A to the power 0. So it is 0 order reaction. It can be 0. It can be 0, positive, and fractional. Next, it determines the rate of reaction. Right, next. It changes with external factors such as temperature, pressure, etc. All of you done? Is one of you tell me?
Yes.
Yes. Okay. Okay. Now we are going to write about. See, when we have different order of reaction, the unit of the rate constant is going to be different. Okay, the unit of rate constant is going to be different. Please write units of rate constant for different order of reaction. For the first one, you will write zero order reaction. Okay, so let us see what is happening in the zero order reaction. Please listen very carefully right now. Okay, please listen very carefully. A giving me B. Okay, A is giving me B. Here the rate is equal to K, and it is zero order. That is why it will be what? A to the power 0. A to the power 0. Okay. Now I'm just going to write the unit of rate. What is the unit of rate? Tell me, guys, all of you. What we have seen, what is the unit of rate always? Moles per liter Moles per liter. Tell me.
Second.
Moles per liter per second. Okay. Now this will be K. And what is a to the power 0? Whatever it is a to the power, it will be what? It will be 1. Correct. So I can see that now we can say that K is equal to also what? The unit of K is going to be moles per liter per second. Is that clear? Yes or no? Please tell me, guys. Clear है ये zero order reaction के लिए?
Yes, sir.
Right. Now let us look at the first order reaction. ठीक है? Let's look at first order reaction. You have the same reaction. A is giving me B. Here, rate is equal to K into the concentration of A to the power 1. K into concentration of A to the power 1. Now I'm going to write what is the rate. Rate is written as always moles per liter per second. And we have to determine the unit of K. So I will just write K as it is. What is concentration of A? Concentration of A is always written moles per liter. It is always written in moles per liter. Now what is equal to K? K will be equal to, this will go down and you will have moles per liter per second divided by moles per liter. Here we can cancel the mole. Here we can cancel the liter inverse also. Okay. So what will be the unit of K? Second inverse. Got it? Yes or no? Please tell me, guys.
Yes, sir.
Okay. Right. Next. इसको लिख लीजिए दोनों को. Done? Yes or no? Please tell me. Let me know when you're done. Okay.
Done, sir.
Done. Right. Next. Second order reaction. And second order reaction आप लोग please start कर दीजिए अगर आप लोग को करना है तो. A to B rate will be equal to the rate constant into the concentration of A now square. Now we will write the unit for rate, that is moles per liter per second, which is equal to K as it is because we have to determine the unit of K, and A square will be what? It is moles per liter whole square, and K will be equal to now moles per liter divided by, I can write per second. I can write this as moles per liter and also one more moles per liter. Yes or no? Please tell me, guys. And then we can cancel one of these. So the unit of K will be equal to, this mole will go above, it will become liter in mole inverse. Mole inverse, liter inverse will go above, it will become liter, and it second inverse is as it is, second inverse. So this is the unit of K when it is second order reaction. Please write this down. All of you done? Yes or no? Please tell me.
Yes, sir.
Just a second. Sorry for that. Okay, now I want you to focus here. Okay, what is the power on liter for the zero order? Tell me, guys. What is the power on liter?
minus
Loudly. Nawal and Rifat, आप लोग को नहीं दिख रहा क्या? What is the power here?
-1.
1 minus 1. What is the power of liter when it is order is 1? Liter का power क्या हम 0 बोल सकते हैं? Yes or no?
Yes.
Yes.
And for the second order, it is liter to the power 1 plus 1, correct? Yes or no? Okay, so we can say that you just add 1 to the power of liter and you are going to get the order, correct? -1 plus 1, 0. 0 plus 1, 1. Plus 1 plus 2, 2. Right? And similarly, for 3, it will be what? This now, liter will be 2. Second inverse is as it is, as you can see. Right? Mole will be having the same power as that of liter, but in the inverse. Got it? Please write this down. Write a note. Just add plus 1 to the power of liter in the unit of rate constant to get the order of reaction. Okay, and we can write in general unit of K is equal to unit of K, it is equal to moles per liter to the power 1 minus n second inverse. Okay, to the power 1 minus n second inverse. And what is n here? Here n is equal to the order of reaction. Okay, n is equal to order of reaction. Start writing questions. Okay, write this down and solve these questions. You can see the rate constant unit is given. Send the answer on WhatsApp or just you can send in the chat also. Okay, this is question number 1. This is question number 2. Question number 2 ka one part and second part. Ignore this reaction like this. Okay, send the answer here. I'm just coming. Okay, Hanifa, first one. Yeah, first one is correct. Second one, correct. Nawal, correct. Very good. Rifat, just waiting for you. No, Rifat got disconnected. Just write one more question. Then all of you. What will be the order of reaction for this third one? Send the answer in chat. Okay, first one. Okay. Hanifa, this one is for the third one, right? Yeah, correct. What happened, Rifat? What about others? जल्दी जल्दी आंसर कर दीजिए ना, कॉमा से सेपरेट करके आंसर कर दीजिए बस. Are you writing the question? No, रिफत नहीं, सेकंड वाला गलत है रिफत. प्लीज देखिए दोबारा. प्लीज डोंट डू दैट मिस्टेक. सिर्फ लीटर को देखना है आपको. ओके, जस्ट ऐड 1 to लीटर. Whatever the power of liter is, just add 1 to it. Rifat, please turn your mic on.
Yes, sir.
What is the power of liter in seconds? First question. What is the power of liter?
Sir, 0.
What is the power of liter for the second first one?
1.
Yeah.
So
Now-
the order is 0.
It is -1. The liter is power -1, not 1. -1, and the order will be 0. Yeah. Write another question. for a reaction rate of reaction becomes 27 times concentration of reactant. Yeah, now it is correct. Concentration of reactant X is increased 3 times. Find the order of reaction. Find the order of reaction. Okay. Please look at this one. It's quite simple. Now, read the question, what it is saying. Okay. Read it very patiently. For a reaction 2x giving x2, rate of reaction becomes 27 times. What it is saying, it becomes 27 times. यानी कि पहले कुछ और था, right? Before 27 times, it was one time. Like it was plain simple something, right? So for the first thing, what we are going to write, we are going to write the two rate equations. What you are going to write first of all, when rate was equal to the rate constant times x to the power n. Okay, x to the power n. N is the order of reaction that we have to calculate. Okay. Now it becomes 27 times. When it becomes 27 times, the rate becomes 27 times when the concentration of x is increased 3 times. That means it is 3x. And the order is going to be the same. Can all of you see this see these two equations? Yes or no? Please tell me, guys. In the question itself. नहीं, यहाँ पे नहीं बोल रहे हम दिख रहा है कि नहीं दिख रहा है. आपको यहाँ पे ये दोनों दिख रहा है कि नहीं दिख रहा है यहाँ पे. Can you see these two equations in the question? That is my. वो आप पूछ रहे हैं. That's what I want to know. Can you see these two equations in the question? Yes or no?
Yes, sir.
ठीक है. अब वो दिखना चाहिए आप लोग को. Okay. Now what we can do? We can just divide 2 by 1. Whatever is greater, you just divide that. It will be easier for you to get. 2 divided by 1. And that means 27R is equal to K 3x to the power n divided by R divided by K x to the power n. Now this R and R can get cancelled. K and K can get cancelled. And 27 will be equal to 3 to the power n x to the power n upon x to the power n. X to the power n, x to the power n will get cancelled. And this will be equal to 27. I can write it as 3's cube. And this is also 3 to the power n. That means n is equal to 3. All of you got this? Yes or no? Please tell me, guys. All of you got this? Yes or no?
Yes, sir.
Okay. Check. All of you wrote this? है ना? जब लिख लीजिएगा तो फिर अच्छे से बिल्कुल यहाँ पे ऐसे लिख लीजिएगा. Order of reaction is equal to 3. Write this question. Now, first thing, plain simple rate of reaction. Whenever you get this type of question, you will write first of all the plain simple rate of reaction. That means R is equal to, let us suppose the reaction is A giving me some product P. And that means I can write, let's suppose R it is equal to rate constant into the concentration of A. What should be the power of A? Tell me guys, according to the question. What should be the power of A? जोर से बोलिएगा please, जो भी बोलिएगा. According to the question, what should be the power of A? Loudly. नहीं chat में लिखिए फिर आप लोग, आवाज ही नहीं है किसी की. What should be the power of A? Yes, Rifat, correct. Hanifa and Nawal, please answer. What should be the power of A? What should be the power of A? It is given in the question only. Okay, read the question. If you are not getting it on top of your head, read the question multiple times. Yes. Yes, correct. 2n नहीं होगा नवाल, it will be just 2. यहाँ पे दिया हुआ है आपको ऑर्डर ऑफ रिएक्शन. जब आपको निकालना रहेगा तब आप वहां पे क्या ले लीजिएगा, कोई वेरिएबल ले लीजिएगा, x ले लीजिए, a ले लीजिए, b ले लीजिए, n ले लीजिए, कुछ भी ले लीजिए. Got it नवाल? They have already given a second order. तो यहाँ पे हम क्या लिखेंगे, 2 लिखेंगे. Okay, we'll write it 2. Now what they are saying, how will its reaction rate be affected if the concentration of reactant is double? अब हम लोग को क्या करना है, let us see. What should be the R? This is what, this one is R1, this is R2. Second rate of reaction. जब आपके पास क्या हो जाए, A की concentration double हो जाए, so we'll have K. Now the concentration of A is double, that means it will be 2A, and the order will be same, that is 2. This will be equal to K into 2 square and the concentration of A squared. So I can write this as 4 K into the concentration of A squared, and this is nothing but this is the R1. So it will become what? 4 times. If the concentration of reactant is double, the rate becomes 4 times. 4 times. Okay. Rate becomes 4 times. For this, I'm going to write, if it is now R3 will be equal to K. Now what we have done, half it. So A divided by 2, this complete thing will be in the square. You will get this as K 1 upon 4 A square. This will be equal to 1 upon 4 K into A square. Now this is your R3. We can write R3 is equal to 1 by 4 of R1. So it decreases by 4 times. Okay, when it is reduced to half, it is decreasing by 4 times. लिखिए सबने.
Yes, sir.
Okay, just a second. Should I write this? पहले plain simple rate law लिखिएगा. Okay, when we have not increased anything, not decreased anything, जब आपके पास A की concentration A है, B की concentration B है, first of all write that and give it a name as R1. Okay, give it as a name as R1. In the first case, what we are doing, how is the rate of reaction affected if the concentration of B is doubled? उसमें आप क्या कीजिएगा, R2 is equal to the rate constant K concentration of A. There is no change in the concentration of A, so concentration of A will be as it is. But in the concentration of B term, what you will write 2B. Why 2B? Because we have doubled it. Okay, and the square will be still there. And then just determine what is the rate of, how the rate is going to be affected, how it is going to be changed. Once you are done, you will send the answer to me on WhatsApp. Okay. Is anyone stuck? Tell me. Is anyone stuck? No. You guys are doing? Okay. Yeah, very good, Nawal. That is correct. Hanifa and Rifat, tell me. Rifat, are you stuck?
No, sir, I'm done.
Doing. ठीक है, जल्दी कीजिए. आपको दो रिएक्शन, दो रेट लॉ लिखने हैं 1 and 2, जिसमें 2 में 2 भी होगा, स्क्वायर कीजिए, दोनों को डिवाइड कर दीजिए फिर, या फिर आप दोनों को अलग अलग से लिख लीजिए और उसके बाद फिर वी विल गेट द आंसर.
Sir, I got the answer, but I can't send the photo.
Tell me how many times? What will be?
Four.
How it will be written? 4 times. Yeah, that is correct. So R1 is going to be equal to K into A and B square, and R2 is going to be K into A 2B square. I can write this as K into A 4B square, and I can write this as 4 into, sorry, and this is nothing but R1. Okay, Hanif also sent. Yeah, correct. Very good. Chalo. Okay, fine. So that's it for today, guys. Okay, we'll see some more questions in the next part, and mostly now it will be questions. I think the next class will be mostly questions. And what we are doing here, if you see, we are determining the order of reaction. Okay, why? Because it is the only thing that is experimentally determined. We're determining the order of reaction, and hence we are determining the rate of reaction. Okay. After this, we'll look at the mechanisms. Okay, there will be a little theory. I think maybe we can touch up a bit of theory tomorrow. Mechanisms. Okay. And it's going to be a small chapter. And then in the next week, maybe we can start the types of order of reaction. That is the main part. Okay. So next week, Saturday, Sunday, it will be very important. May you will be learning about the integrated rate law. In one of the classes, I will be completely doing the derivation and all for all of the different types of order of reaction, first order, second order, third order. And after that, one Sunday will be completely for numericals. Also, one more thing, log. All of you guys know log, right? है ना? इलेक्ट्रोकेमिस्ट्री में पढ़ाया था हमने, राइट? उसको रिवाइज कर लीजिएगा, ठीक है? प्लीज रिवाइज दैट. कल तो नहीं, कल नहीं चाहिए होगा, नेक्स्ट वीक चाहिए होगा. आई विल रिमाइंड यू टुमारो आल्सो about that. Okay, so log will be required, and Sunday will be mostly A, and then I think